Welcome to the TechSwami podcast, where we talk about the decisions behind the software, not just code, tools, or frameworks, but the thinking that shapes systems as they grow. I'm your host, Vijay, and I've spent the better part of the last decade working with startups, building systems, tooling, frameworks, and more. If you're a founder, a senior engineer, or someone responsible for technical decisions, this podcast is for you. In each episode, I'll pick one idea that quietly makes or breaks scaling teams and unpack it from first principles using real trade offs, real constraints, and real consequences. Let's get into today's topic. We need to talk about microservices. I hear this sentence a lot. Let's go microservices. Engineering teams love to do microservices. They're almost itching to do it. Sometimes it's absolutely for the right reasons, but sometimes it's not. Every time I hear engineers talk about going with microservices, I want to slow the conversation down. Not because microservices are bad, but because that sentence hides a lot of assumptions. It assumes the architecture is the problem. It assumes decomposition will restore speed. And it assumes the cost of microservices is lower than the pain you're currently feeling. Microservices are a trade-off, like everything else in engineering. They change the shape of almost everything. How failures happen, how data behaves, how debugging works, how teams communicate, and how much tooling you need just to understand what's going on. So in this episode, I'd like to talk about microservices, what they are, what they're not, what trade-offs you make when you do use them, how I think about designing microservices, what the quote-unquote right size is, and what are some of the signals you should look out for that tell you they are the right solution. Before we dive into all that though, I'd like to rewind a little bit. We need to talk about what microservices are not. A microservice is not just a small service. It's not one service per endpoint. It's not one service per table. It's definitely not whatever fits nicely in a repository. A microservice is an independently deployable unit that owns a business capability. And I really need to drill this in. Not technical layering, not code organization, a business capability. Something the business can point to and say, this does this thing. When teams miss that, what they end up with is a bunch of tiny services that can't move independently. They all talk to each other constantly. They share assumptions. Sometimes they even share databases. That shared database one is a lot more common than you think. I've seen that way too often. And at that point, you haven't really escaped the monolith, have you? You've just made it harder to reason about. Now, here's the part that usually surprises people. The monolith is not the enemy. A monolith is just a single deployable unit. That's it. It says nothing about quality. You can have a terrible monolith. You can also have a very well-structured one. In fact, for most teams, especially early on, a monolith is the strongest place to start. One code base, one deployment, clear internal boundaries through modules and packages, strong separation between domains, rules about who can talk to what. The reason this works so well is not philosophical, it's practical. You get single deployments, you get local development that doesn't require spinning up half the company's infrastructure, you get real asset transactions that actually work, and you can observe the system with just well-structured logs, no fancy observability, distributed tracing, etc. I mean, you could have those, but they're not a prerequisite. Most importantly, you get something else, learning. A monolith lets you learn how your system actually behaves under load before you lock boundaries in place. And that's where I've seen teams usually go wrong. They decide to quote-unquote go microservices too early. Before they really understand their domains, before usage patterns settle, before they know what truly needs to scale independently, before they have the operational maturity to handle distributed systems. So instead of letting boundaries emerge from actual usage data, they guess. They split based on team structure or the future scale they imagine or examples they've seen online. And once you split, things get concrete. APIs become contracts. Data gets separated. Failures stop being local. Reversing this decision gets much more expensive. This is why my bias is very simple. Start with the monolith, make it modular, and only decompose when the system itself starts pushing back. And when it does push back, it's usually pretty clear if you're paying attention. So when does splitting make sense? Well, from my experience, there are really 4 critical signals that I look out for. If you don't have at least one of these causing you real pain, real tangible pain, you're probably splitting too early. Okay, so let's look at these 4 signals. First, deployment pain. And I don't just mean slow deployments, I mean risky ones, where the blast radius for any small change is the entire application. So changing a simple calculation has a non-zero chance of breaking, let's say, user logins. That's a huge signal. The second one is scaling divergence, meaning different parts of the system have different needs, wildly different needs. Your real-time notification system might need to be low latency and scale horizontally across 100 machines. But your end-of-month reporting system needs one giant machine with tons of memory for a few hours. When you can't scale them together efficiently, it's time to split them. Third is coordination overhead. This is a people problem. Your teams are constantly in meetings just to coordinate simple changes. Knowledge gets siloed, and there are parts of the code that everyone is afraid to touch, except for that one person. The organizational structure is kind of fighting the code structure. The last one is about data needs. Different parts of your system start to have a very different set of requirements for things like consistency or data life cycles or their core business rules. Those are signals, not Kubernetes, not blog posts, not this is how the big companies do it. Signals from the system you actually have. Now, once you decide to split, the next kind of natural question is, how big should the service be? And again, they're usually looking for a number. But the real answer is actually a lot less satisfying, but a lot more useful. A microservice is the right size when it can change independently without affecting other systems. If every meaningful change requires coordinating with other teams, syncing releases, or updating multiple consumers, then the boundary is wrong, even if the service is tiny. And if a service is relatively large but cohesive, owned by one team and evolves predictably, that's okay. So size isn't the thing you're trying to optimize for, coupling is. A microservice really needs to be treated like a black box. Here's how I think of it. As a consumer of a service, you can't see inside. All you see is the public contract. That is the APIs, the events, the webhooks, etc. that you use to get an outcome. You don't know what database it's using, or even if it is using one, if it's using a cache, if it's behind a load balancer. It is merely a set of capabilities that you call, much like libraries in code. But you don't know and should not care about its implementation. So, if your service represents something coherent to the business, like billing or inventory management, then you can start to draw boundaries and write the contract for that service. At this point, event-driven architecture often enters the conversation, and again, for good reasons. Events let you reduce synchronous coupling. They let parts of the system evolve independently. They make certain workflows much more natural. But again, they come with a cost. You've given up immediate consistency, you give up simple mental models, and you give up easy debugging. Failures don't disappear, they just show up in different places. Event-driven systems work best when the business process itself is asynchronous, when consumers don't need instant answers, and when you're okay accepting that understanding of what happened might take some work. Which brings me to the last and certainly not the least part of moving to microservices. Tooling. Microservices without strong tooling is a foot gun. In a monolith, weak observability is annoying, but it's survivable. In microservices, it's catastrophic. Imagine you have 5 different services: auth, orders, payments, and shipping, and probably another one. When a request from a user hits your APIs, it's likely going to go through more than just one service. You've got auth to make sure the person is identified, then you have orders and payments, and finally shipping. You need to be able to trace this request across all of those services. You need logs that actually correlate. You need metrics you trust. You need dashboards that tell a story. Without that, you've traded visible patterns for invisible ones. And that's why microservices aren't just an architectural choice, they're an organizational and operational commitment. So when teams want to move to microservices, the real questions I want them to answer are these. What signal are you responding to? What independence do you actually need? And are you ready to pay the cost, not just in code, but in tooling, operations, and discipline? With a deep consideration of the trade-offs, you're going to set yourself up for success, knowing fully well what you're buying into. If you're a small company that's only got maybe 10 to 20 engineers, start simple. Just design a modular monolith and watch for those signals. Because microservices don't necessarily buy you speed, they buy you independence at the cost of complexity. If you don't need that independence yet, don't pay for it. So that's it for today's episode of the Text For Me podcast. If you'd like to hear about event-driven architecture, Kafka, and related topics, I'd love to know. Drop it in the comments. Thanks for listening.